Hello and welcome everyone. My name is Peter Robinson and this is the Ethereum Engineering Group Meetup. Today we've got Artem Chistikov and he's going to talk about an EIP that he's been working on about account abstraction recovery. So please, Artem, please introduce yourself before you present your slides.
Hello, everyone. So my name is Artem. So currently, I am a Solidity developer at Distributed, working on a lot of topics mostly connected with cryptography and Ethereum. Author of 3 EAPs, and today I would like to show you and present you the latest one, the EAP 7947, which is the account abstraction recovery interface. And yeah, I think I can share the screen right away.
Yes, please do.
Yeah, just a second. Just a second. This one. So yeah, just as I said, ERC 7947 on the abstraction recovery interface. We'll talk about it in more detail, the motivation behind this ERC, and also a bit beyond, like what I think can be done on top of this ERC going into the future. So let's start. So first of all, the recap, just I'm sure that you're all familiar with all those concepts, but I'll be talking about them quite a lot. So let's just quickly go over them and just remind ourselves the differences. So first of all, externally owned account. This is the regular account on Ethereum. It has a private key. You can send transactions, and importantly, it doesn't have bytecode. So before the latest Spectra fork on Ethereum, this account could only initiate transactions. That was basically it. So after Spectra, we have 7702. It can place a bytecode under the EOA, but this is we'll talk about it later. The smart contract, it doesn't have a private key, so it can't initiate transactions, but it has bytecode, which allows this contract to react and have really interesting logic written within. And the seed phrase is just a randomness from which we derive a private key using a BIP39 standard, which is also used in Ethereum. And two main aspects that I wanted to highlight here. First is that before the BIP39, we just had private keys lying around, and it was really hard to remember them. So some brilliant folks came up with this concept of seed phrases, where we can break up this randomness into words, like 12 words up to 24 words that we can easily, in quotes, remember, but actually it's really hard to actually remember them. You can write them down and hide somewhere, but to keep them in your memory is quite challenging. And this BIP is quite old already. It's like 10 years old, and I think going forward we have much more clever solutions when it comes to seed phrases. So the next one. Yeah, the GX end game for Ethereum is basically to combine the externally owned account smart contracts to have one instance that can initiate transactions, and where we can also have some bytecode where we can react to those transactions. And the importantly is to never deal with seed phrases again. If we could somehow combine all those three, this would be the best UX possible for Ethereum, because the onboarding of new users would be really simple. No, like remember, write down the seed phrase, and we could do like multi-calls, one transaction. We could do transaction sponsorship, so users wouldn't need to hold either to initiate transactions. We could do it because of this combination. Yes. So account abstraction is quite an important concept in terms of Ethereum ecosystem. It was around for quite a while, and basically it tries to solve the first problem, the problem of combination of externally owned account and a contract, but it doesn't like directly solve the problem of seed phrase. So by combining those, users can now operate smart contracts with custom logic. Yeah, we can do multi-calls, we can do gas sponsorship, we can do, I know, for example, when some wallet provides this account for users, they can pay for every transaction initiated from that wallet. Also, we can add logic for account recovery. We can add like a lot of cool things impossible without this combination. And the most popular standards right now are ERC 4337 and EAP 7702. So this one is an ERC because it doesn't require any protocol layer modifications. And 4337 is just a set of smart contracts and some off-chain components. I think they're called batchers. That's just you can deploy on any chain. That's why it's called an ERC. And EAP 7702 has been recently enabled with the Pectra fork on Ethereum. And basically this one allows you to set like a special delegation bytecode underneath your externally owned account, so that when you call your account, you can execute custom logic for the aforementioned use cases. There is one caveat in regards to 7702 is that the private key that controls this account can always like undelegate this logic that you set up. So basically you can set a new bytecode, and at any point of time, you can unset this bytecode. And this basically means that the private key that controls the account is a super user, like that we can't limit in any ways, which is not super cool. For example, if your key gets compromised, there is no logic right now within the Ethereum that would allow you to recover the funds, because they can just undelegate your whole logic from the smart account. That is one caveat here with the 4337. Yeah, it's different, so no problem here. Yes, and account abstraction doesn't directly lift the requirements of seed phrases because it's a bit different concept. It doesn't actually care how you would derive this private key to control your account. It just aggregates this logic. And because smart accounts are basically smart contracts, they can be extended with clever standards and some advanced cryptography tech to improve the UX even further. Yeah, so one of the extensions that is possible that I came up with is the account abstraction recovery interface. So actually, there were a lot of talks with account abstraction that, yeah, we now have bytecodes, we now have smart contracts. Maybe it's possible to do some social recovery within those smart accounts. And yeah, it's possible to do, but how would you do it actually? Like there is no interface to follow. There's no something that you can just read and implement. It was all like abstract in the air. So what I decided to do is just to define those interfaces, very, very simple form, and just try to solve this this problem of onboarding. So usually smart accounts are operated by some authority user that has private key, which basically is needed to authenticate the action on this smart account. How this private key gets derived is not our concern right now, but what is our concern is that if this private key gets lost, so the very important word lost, but not stolen, we can, so basically when it can get lost, if you are using some wallet, so it internally stores this private key, and if you uninstall this wallet, then it's possible that you forgot to write down the seed phrase, so you don't have an access afterwards because it just gets deleted and that's it. But on the blockchain, the funds are still there, so you would want to somehow recover them, but computing the seed phrase is quite impossible. Computing the private key is also quite impossible. So the only way is to do some external external proof that you actually owned this account previously. So this external proof and method can be standardized. We can define some interfaces just to make it a bit more secure, because it would give through a lot of peer review, and because it's an ERC, it would also become available across the ecosystem for the further usage. So here is the pure code for the account abstraction recovery standard. So let's just quickly understand. It's a very simple interface. It's a very simple standard. So how it works? Basically, the ERC defines two interfaces. The first one is account recovery. The second one is recovery provider. And basically, it provides a means of communication between accounts and recovery providers, where when you have accounts available, so when you set it up, when you're using it, you can subscribe to a recovery provider. Let's say you developed one yourself, or a service that provides some recovery. You can subscribe to this recovery provider and commit to some secret that you would like to prove later, that you are the owner of the smart account. So you subscribe, and then after some time, you can recover. The function is called recover, but basically what it does is that inside it, you have some proof that proves that you know the secret to the commitment that you subscribe to. And if that's okay, if that passes, then recovery provider says, cool, you know the secret, you can change the owner of the smart account. So this is basically the whole flow. Here are the interfaces, and maybe this would be a bit more understandable. So basically, 4 functions here and 4 functions there. On the account recovery side, we have add recovery provider function, which should be access controlled. So this is an interface. So It's just defined here, but when you implement it in the actual account, it needs to be access controlled. I know, like only owner access. And at any point of time, the account can add the recovery provider, this one, and provide the recovery data. Recovery data is this commitment that we would like to commit to. This can be like a hash of your password. This can be some, I don't know, proof of passport commitment. This can be, I know, some other public key that you would want to, I know, check the signature of. This can be literally anything. And when a user calls add recovery provider function, it calls the subscribe function on the provider. Then we have remove recovery provider, which calls unsubscribe and basically removes all this data from the recovery on the recovery provider side. Then a super simple function to check if the recovery provider has been previously added to the account. And the most significant one is recover ownership, where we pass the new owner that we would like to recover ownership to, the recovery provider, which has been previously added to the account, and the proof of knowledge of this password or proof of passport or anything that basically gets transferred, it gets called here. And this proof is basically this proof, and recovery provider can check this previous like commitment link. And if it's okay, then recovery provider returns true, and we can change the owner of this account to this newly passed owner. So as simple as that. Let's check what is possible actually with this kind of communication. So first of all, this very simple design, which is basically two interfaces, is compatible with almost any smart account. So you can use any existing implementation of a smart account from Infinitism, from I know MetaMask, from any library you like, and you can easily extend it with those interfaces on the previous slide, because you would still have this ownership mechanism, and just adding several new functions is not a big deal. Secondly, we can have like an ecosystem of those recovery providers living somewhere. This can be a website, this can be within the wallets, this can be like an aggregator of implementations. And recovery providers may provide like a variety of recovery services, like through a password, through national password, socials, ZK, ML, like whatever you want. And this is up to a provider to decide, and to a user to decide which provider to use, which they like, fully up to them. Then we don't need to actually trust the recovery providers, because we can use zero knowledge proofs for like to compute this secret on your device and never reveal it to the outside world. Because in the subscribe function, we are passing some bytes, some commitment. Recovery provider doesn't know what this commitment is. They just they would just store it inside their like storage, and then we are passing some abstract proof where we never reveal these secrets, and we would just check it as normal zero knowledge proof. If it passes, then yes, we know the secret to the previous commitment. So no data shared with anyone, fully on device. Pretty cool stuff. Then we also have a economical incentive here. So it's possible for recovery providers to charge some subscription fees if they want, because by design, the account has to call the subscribe function, and inside the subscribe function, recovery provider can try to transfer USDC or require the payment in ETH, which is pretty cool. Then we can possibly have this recovery provider marketplaces emerged. For example, this can remind you of Uniswap version 4 hooks. So there are like websites where a lot of community and established companies share their implementations of Uniswap hooks. Those hooks can also like charge fees or something, but they're like available to the public, and this EAP also allows this like marketplace to exist, where basically user would go to, and with their MetaMask, they could sign up for the 7702 delegation, where user could choose which account to use. And inside this account, they could also say that, okay, I want this recovery provider to be added as a recovery option. And this is going a bit in the future, going a bit forward. So in combination with some 2FA, like ZK2FA, where this second factor two-factor authentication is added to every function within the account. So when you want to transfer funds, or you want to execute some logic, you would provide some additional authentication along with the private key signature. And if we have this, we no longer need to remember the seed phrase again. So why is that? Because the seed phrase is just like something that's needed to authenticate yourself. But if we can authenticate with an additional method, and then if we can recover to a new seed phrase, basically whenever we want. So we don't need to remember it again. We can use the wallets as normal. We can delete these wallets, and okay, when you want to recover it, you have means for that. If your seed phrase gets ever like stolen or compromised, you still have a second two-factor authentication that doesn't allow your funds to be just easily transferred from your account. And if that's the case, you still have some time to recover to a new seed phrase, like to recover to a new ownership, and basically the loop starts all over again. And that's why, like I really love this phrase, the sentence that the seed phrase is a toxic waste. So ideally, going into the future, at least to me, we no longer need seed phrases, and ideally is to like not store them anywhere, because we can always like we already have tech to generate private keys from better randomness, from better entropy than just seed phrase that you must remember somewhere. And yeah, one of the like options to use here to extract this entropy This option is called fuzzy extractor, and basically what it enables you to do is extract some random sample, some random string of fixed size from biometric data, image data, and the cool part is it also has a noise tolerance. So it shouldn't be exactly the same image, exactly the same like biometric footprint. This fuzzy extractor is clever enough to understand like the patterns and extract the exact private key, even if there is some noise on the image. And we can use some kind of those fuzzy extractors inside the wallets to generate private keys from real-world objects only the user has access to. So, for example, you worked at some office, and opposite to an office there was a really cool view, or there was a very cool building that you remember, and you can take a photo of this building. So like some angle or the corner of this building, so only you would know where this private key gets derived of, and you also would always remember this exact place, because remembering the seed phrase is quite hard, so no one remembers these 12 words. But remembering images, remembering places is much easier for humans than just words. And with some cool entropy, we can achieve the same like security aims. And you would also never like forget where to place your smartphone to extract the same private key. And in combination with AI, those fuzzy extractors can do like really cool things. So the end game sort of for the UX, of course, it's account abstraction. So account abstraction is needed for this custom smart contracts logic to like merge the usage of like the current usage of externally owned accounts, because they have private key, they can initiate transactions with custom smart contract logic to be able to actually implement all of that. The usage of fuzzy extractors to generate private keys from real-world objects to never have the seed phrase popping up over again. So we can have a UX where we display to a user that, okay, you need to generate a private key right now, and take a photo of something memorable, something only you have access to, after that, the private key gets extracted from this image, which can be reproduced. Then for every action on the wallet is to require a 2FA. This can be any 2FA, but usually this would require also some zero knowledge proof, and because we don't want to reveal those secrets to the outside world. And currently it's already possible to have a very simple face recognition neural network to be like packed into the zero knowledge proof with some low liveliness check. So the third point here is not like production safe as of now, but I think in several years it would be absolutely possible to have like a really strong recognition network we put into zero knowledge proofs with a very high liveliness check. What I mean here is this proof would also identify whether you took the picture like right now, or it's just some random photo from the internet of yourself. And if this liveness check is very high, we can be sure that whenever the user signs the transaction, and we require this user to issue this proof, is that he's issuing it like in real time right now, and yeah, basically providing a two-factor authentication. And fourth, the last but not least, is in case of the private key loss. So yes, of course, you can still reconstruct it from the real world object that you would hopefully remember, much easier than remembering those 12 words. You could still recover an account to a different real world object, sort of. Yeah, and the recovery is basically made through showing the knowledge of some alternative secret, a zero knowledge proof, which is basically the ERC that the ERC 7947 that we were talking about. So, yep, the ERC is just one small step in this big picture of really cool UX, and I'm really hoping that in the future we'll have it all. But yeah, right now these are more like small steps in this big like direction. And yeah, the ocean revolution is here. Yep, so that's it.
Yeah, well, there are some questions in the chat that were from about 20 minutes or 10 minutes and 20 minutes ago, some slides ago. And I'll read them out. So is the authority a type of multi-sig?
So I think it was about this one. This is authority.
Yeah.
Yeah, but the thing is, for multi-sig, we don't need account abstraction. Because yeah, multi-sigs exist and they're just regular smart contracts. But here, like an authority is actually a user, and I put like this word here because this can be like this user can have many like key pairs. Let's say one can be like the sec, one can be the baby jab because it's easier to prove those signatures in zero knowledge proofs. So that's why I put like authority here.
The other question that Devendran had was, so this was at 22 plus, this is a few slides later, but where does the proof get stored on chain? And is it hashed and stored? If yes, what is the hashing used, or how can it be used? So I think he was looking at what you were saying and grappling with how does it, like what is this, what's the proof value, and then what I know what secret gets stored. How say, for instance, the simplest example, I think, being, say, a password, how would that really work, I think, is what he's getting at.
Yep. So yeah, basically the first step is to provide this commitment to some secret. So in a simplest form, this can be a hash of the secret, but storing hashes of secrets on chain is not really a good security point, because yeah, anyone can like try to brute force it, and then your like password gets leaked. But if it's something more complex than that, let's say this can be some very complex structure of passport. So I've been working on a project where we do those zero knowledge proofs of passports on chain, and basically what this project does is that we store like we create sort of an identity and proof that your when you create this identity, we prove that your passport has been issued like correctly. We rebuild all those signatures within this passport issuance chain, and yeah, there are actually two levels of those signatures: intermediate certificates and master certificates. So we can reconstruct this chain and prove that your like passport is a legit one issued by some legit government. And because it's made in the zero knowledge proof, no data gets like shared with anyone, only fully on your device. And you can basically store this information inside the commitment. Yep, that you have like certain passport, certain data, and then in the proof, this one, when you recover the ownership, you can pass the data that would like match the one that you committed to. And because this is fully done by you, you can store like basically anything here and prove anything here. And for the outside world, like no one would understand what you're doing here, what you're committing to, what you're proving. And yeah, because if your private key gets lost, so how an attacker would understand what to do here? These are just some random like commitments. Yeah, this is up to wallets to decide, to some website where this interaction happens to decide what commitment means and what proofs to provide. But yeah, it can be anything. Yep, Peter, you're muted. Yep.
Sure. So when I was looking at that, I was thinking about how you would do it. And as you say, just a simple hash wouldn't work. And the reason I was thinking a simple hash wouldn't work is when you reveal the pre-image, someone could grab it and front run you with your pre-image. So
But you're never revealing your pre-image. That's the beauty.
yeah. Well, if you were just had a hash of the pre-image, you'd need that'd be the only way. But yeah. If you had a ZK thing, I was wondering whether you couldn't have the have like a secret, like like a word that like a password, and you have as a public value just an integer, and then you hash those together, and then you prove that in zero knowledge. um, Somehow. Anyway, I don't know. Maybe I guess I haven't thought through. I was thinking but how you're saying with essentially like a certificate authority and proving that seems like a very good idea, and also matches how governments do things.
Yeah, and in terms of front running, just real quick. So you're never revealing the actual secrets because it's hidden in the zero knowledge proof,
Mm,
and what you are using as a public output is what you have committed previously. But to never get front run, you must also include this new owner address into the zero knowledge proof.
mm,
So then if you even get front run, you would still like recover to this owner, your desired owner. So
Yeah,
it's like
but you're tying the
not,
two things together.
yep, yep.
Yeah,
So it's not an issue.
yeah, that sounds very good. Oh well,
But
awesome.
yeah, just one concern with the hashes is that you shouldn't really store hashes of your passwords off chain because yeah, they are like eternally bound to like on chain, and anyone could try to like brute force them.
Yeah,
Um,
yeah, yeah. Even if your password's 100 characters long, sooner or later
yeah,
someone will break it. Yeah.
yeah,
Yes, it might take 50 years, but at some point technology will catch up. Yeah.
yeah, probably.
Another thought, though, that you were talking about using the fuzzers and you'd say take a photograph of something and you would know. So, I don't know, being pretty old, as it were, what I've noticed is that people knock buildings down and, or things that you had readily available to you at one point, 5 years later, you can't find anymore. So,
Yeah,
yeah, I ponder about that.
yeah. That's a problem, but it is still fundamentally much more simple to remember some image, yes, than the strict order of 12 words that you don't use like very often. And even if this building gets demolished, then yeah, you have an option to recover.
Hmm. Yeah, hopefully you
So
have a photograph. Um,
yeah,
yeah.
uh, yeah. So this can be sometimes confused with like regular steganography, but those this tech is much more advanced. So in regular steganography, you basically need to have this exact same image, which
Mm.
basically acts as a password. But here you don't need the exact image. You you can like have a tiny bit different photo, like different lighting conditions, different weather, different angles, just a tiny bit. And this tech would try to compute uh, the correct private key, like regardless. So it may take like several minutes for it to compute because of some different images, tiny bit different images, but eventually it can do it. So no need to store this image anywhere. You just need to remember like the place um, or the object you
Mm.
can like take a photo of.
Okay, right. That sounds very interesting. So thank you. Are there any other questions? Okay, I guess that means you've explained things very well, which is good.
Yep.
Yeah. Can we go to the next slide?
Yep.
Okay, the merch store is open and Artem has gone to the extreme effort of creating QR codes, so thank you. And next slide. Um, oh, I didn't update that. All right, sorry. Yeah, so this talk is today. We have yes, so don't worry about you're too late to turn up to this, and the only way you're seeing it is on the video. But we have three more talks, and in fact, there's now a fourth talk in on the 20th of August coming up. So yeah, and another talk on data. Next slide, please. So this talk will be available on YouTube. If you're watching on YouTube, please come along to the meetup and ask tricky questions. There is a Slack workspace. Please consider joining the Slack and you can join discussions there. From time to time, there is example code as well. And yeah, that repo has all of that code in it. So last opportunity, everyone. Any more questions?
Yeah, we had in the chat something. Oh, yeah.
Yeah. Yeah, and for those watching, thank you very much for a wonderful session, is the comment in chat. So, and I echo that this has been really good. And I know that you've said that you're working on some other EIPs as well. And maybe in
Yeah.
another few months when at some point we can have you on again to talk about them. Because I think that finding out what people are working on in the space is very, very interesting for the audience of this meetup. So thank you for your time creating such a talk today.
Yeah, sure. Thank you for inviting me.
Yeah. All right. Have a great day, everyone, and talk to you all later. Bye-bye.
Yeah, thanks. Bye bye.